Applying a function such as the logarithm or square root to a quantitative variable is called transforming the data. The rules for logarithms are log AB equals log A plus log B. Log A divided by B equals log A minus log B. Log x to the power of p equals p log x. For example, when ln y equals 3x plus 4, you change it to ln e to the power of y equals e to the power of 3x plus 4. Then y equals 3e to the power of 3 to the power of x multiplied by e to the power of 4. Y equals 54.6 multiplied by 20.1 to the power of x. This is an exponential function. Exponential growth increases by a fixed percentage, while linear growth increases by a fixed amount in each equal time period. An exponential growth model, y equals ab to the x, becomes linear when we plot log y against x. A power model, y equals ax to the p, becomes linear when we plot log y against log x. Keep in mind that correlation and regression describes only linear relationships, not exponential. Also remember that correlation R and the regression line are not resistant to influential points. Extrapolation is the use of a regression line for prediction far outside the domain of values. Such predictions are not often accurate. For example, you should not extrapolate when it comes to population because the trend could very easily be changed and your prediction would not be correct. A lurking variable is a variable that is not among the explanatory or response variables and yet may influence the interpretations of relationships among these variables. For example, studies show that men who complain of chest pain received more aggressive treatment than women with similar complaints. The lurking variable is the patient's age and as well as their condition. Women often develop these issues 15 years later than men, and these treatments are more risky for patients, so they may hesitate to advise them. Causation is when variable directly causes the other. For example, rats who have diets with higher levels of saccharin are more likely to develop bladder tumors. Common response variable is when the observed association between the variables is explained by a lurking variable. Two variables are confounded when their effects on a response variable cannot be distinguished from each other. They may be either explanatory or lurking variables. Two-way tables can be used to describe two categorical variables such as education and age group. Simpson's paradox is used to show how the effects of lurking variables can change or even reverse relationships between two categorical variables.